Recorded is relevant. It's Tuesday, March 3rd. We're on lesson 9.6, solving rational equations. Okay, so here's the last lesson of module 9. Get to Alex lesson 9596. That's a single assignment. It's been open a couple days now. Due Friday. Also, your 70% high goal is due in 8 days. So it's March 11th coming up. A lot of you guys achieved that, but so soon, about a week. Tomorrow, Wednesday, we're going to do Module 9 review with Kahoot. So Kahoot review. And then your Module 9 quiz is going to be on Friday. Thursday will be an Alex day. All right, so you guys go with the agenda, what we're doing? Okay. Solving rational equations. Looks like basically solving equations, but they did have some that are maybe a little trickier here, or some interesting situations that I want to go over with you guys. They got mixture problems. They got like working in parallel questions. Okay, so let me flip through, and there's a few I want to do with you guys. Okay, so let's start off with a couple of basic math ones here, just straight down. Okay, and then some of these situations are pretty interesting. So I think I want to do 5 of these with you guys. Okay, so we're going to do 5 for notes. Okay, so write your name on your paper. Everybody wrote your name? You guys wrote your name? Okay, and then this is 9-6 notes. You guys, of course, turn this in and give you guys points for this. All right, we're just going to do 5 puzzles here. All right, you guys ready for 5 puzzles? All right, first one, number 11 from the book. Number 11. All right, of course, if you want to see more examples, you guys know, like always, so got another video uploaded to the classroom. All right, so we got 2f over f squared minus 4. Okay, now I'm going to leave a space for a common denominator. Right, you guys know a common denominator, right? Because we're adding a different fraction. 1 over f minus 2. And that's equal to 2 over f plus 2. Right, so I just took this number 11. It's copied right here. Here, get the book out of the way. Okay. Now, if you sorry, I should have left the space right here. Because guys, look at this denominator right here. It's f squared minus 4. Can you guys factor that? Let's do that. 2f over, how does that factor? Yeah, f plus 2, f minus 2. Okay. And each of those pieces looks like these other denominators. So I think that will be the common denominator, won't it? Okay. So then, actually, sorry, you don't need to space out the first fraction. You need to space out the second fraction. That's what you need. 1 over f minus 2. Okay, guys, leave the space right here. That's what you should do. And then 2 over f plus 2. There we go. That was better. Okay, so you guys wrote it just like that? Okay. Now, as long as you have those spaces there, then you have space to put the common denominator. Okay. So what do you need to multiply top and bottom right here? How about, what do you think? What over what? F plus 2 over f plus 2? Okay. So you guys seen this for a while now. Okay. It's module 9. Okay. Everything I just wrote in pink is equal to what? 1 equal to 1. So we're technically multiplying by 1. But now we do have a common denominator. Matches. And similar idea over here. I need f minus 2 over f minus 2. Okay, so now we got common denominators all across the board. Like I said. Okay. So now we can put everything into one giant fraction. I can distribute this 1 here, which if it was any other number, of course, definitely would not mess that up. So it's going to be 2f plus, and from here I got 1f or just f, and here I got 2. Okay, this is all over f plus 2, f minus 2. Okay, and it's equal to, and then, I got to distribute this 2 right here. So that's 2f minus 4 all over f plus 2, f minus 2. All right, is that true? Okay. All right. Now, there's different ways you can finish this out, but here's a, go ahead.
If it's essentially multiplying, wait, chance.
Yeah. Okay. All right. Now, since this fraction is equal to this fraction, that's what it says. Okay. And also the denominator is equal. Guys, what do you know about the numerators of these fractions? Do they also have to be equal? Yeah. Or you could say the denominators cancel out, however you like. Okay. Now, I will make a little mental note here. Guys, what is f not allowed to ever be equal to? Yeah, plus or minus 2. It can't be negative 2 or positive 2, because then you would be dividing by 0, wouldn't you? Okay, so I'm going to strike the denominators and just continue the math with the numerators only, okay, which will give the correct answer. Okay. But if I happen to get an answer that's negative 2 or 2, I know that's called extraneous. It's not actually a solution. Right? Okay, because otherwise you'd be divided by 0. Okay. All right, so let's pick up from there. So I got 2f plus f plus 2 equals 2f minus 4. Okay, great. Do that. Okay. Subtract 2 from both sides. Okay. And I'm getting f equals -6. That look right? F is -6?
Yeah.
Yeah. All right. That's it. All right. One down. Got one down. All right. You guys got the first one. First one.
Yeah, please use.
I got this one. All right. Next one. Everybody got that in their notes. Oh, yeah. All right. Oh, number 12. Okay, so also copying this out of the book. It says 8 over t squared minus 9. And then let's do plus 4 over t plus 3. Okay. Then I'm going to leave some space here. And it says equal to 1. Equal to 1. Okay, so this is a premise straight from the book. Okay. Okay. Now, the first denominator, I think you guys can factor that as t plus 3, t minus 3. Okay. And then plus, okay, and then this fraction, 4 over t plus 3. Okay. But oh, hey, the second fraction has a denominator that, well, looks like part of the first denominator. Right. But we could get a common denominator right here. You just have to multiply by whatever what? T minus 3 over t minus 3. Okay. And now the denominators do match. Oh, great. That's good. And that's equal to, well, guys, what is 1 equal to? Could that just be t plus 3, t minus 3 over t plus 3, t minus 3? Right. It's not the same thing. That's equal to 1. Okay. All right. And then the next few steps, I think, is going to be pretty similar to what we just did. Right. I got to distribute this 4 here. I do have to FOIL this right side out. First, outside, inside, last. All right, so let's do all that. I got 8 plus, and then I got a 4t and a minus 12. Okay. This is all over crazy denominator. T plus 3, t minus 3. That's equal to, and if I FOIL out this numerator over here, that's t squared. Now, minus 3 plus 3, doesn't that cancel out? So plus 0, and then 3, so minus 9. Okay. And all over t plus 3, t minus 3. Okay. All right, guys got that? That.
Like,
This looks pretty similar to the previous question. Okay, we got all the top all FOILed out and distributed and so on. Okay. And the denominators do match. So I'm going to do the same thing I did with last one. I'm going to strike the denominators if they cancel out, or the numerators must be equal to each other. Okay. But also keep this caveat in the back of my mind that t is not allowed to equal what or what?
3 or 93.
Yeah. Yeah. It can't be anything that would make the denominator equal to 0. Okay. So just in case I get the final answer, if one of those shows up, say, well, okay, actually, that would be extraneous if like t equals 3. Okay, can't do that. Okay. All right, so you guys got that? All right. I think this one's gonna take more than just one page of paper, because if you look at what we have left, we got a t squared term, we got a t term, we have some constants. Ooh, what's this sound like? It's headed toward, starts with a Q. Quadratic. Okay, so let's play this out. Now 8 minus 12 could be -4, so I'll have a 4t minus 4 on the left side. And on the right side, I got the t squared minus 9. Okay. But how you guys have been handling this situation, probably go back to algebra 1, I'm sure, is don't you get everything to one side and get z equal to 0? Right. And then we might be able to factor it, right? Hopefully, but let's see. Right. So
square root 9.
Do what?
You don't want it equal to. Oh yeah.
Okay. So let's do this. Let's subtract over 4t minus 4t. Okay. Subtract over the 4t, and also add 4.
I'm just square rooting 9.
Okay. Okay. All right. So I'm going to end up with a t squared. I subtracted over the 4t, so minus 4t. Okay. Add over 4. Now, -9 plus 4, isn't that -5? Okay. And this whole thing is equal to 0 now. So now we got that. Yeah, I'm pretty sure that's factorable. Okay, that could be what equals 0?
-5
Yeah. T minus 5, t plus 1. Right? Okay, so now factor. Right. And now we're ready for the answer. So t could be equal to, here, I'm going to use these curly brackets, because I think when I designed your quiz, they did something like this. Could be equal to what or what?
-1 5.
Yeah, -1 or +5. Right? Because either of those would zero that out. Okay. So a lot of little stuff, but nothing, I think, extraordinarily new that you haven't seen over the last few weeks. Okay. I mean, took a couple of pages of paper. Okay. So give you guys a review here. What you guys saw. Okay. So that top line right there is straight from the textbook. It's okay. Let's do a common denominator. So multiply top and bottom, get common denominator. Okay. And then I left the denominator basically factored, but the numerator I did a bunch of distribution, did some foiling, right, pulled all that out. Okay. So now we have common denominators across the board. I can strike that. Keep in mind, t cannot be -3 or 3, which we did not give it as an answer anyway, so that's okay. Okay. So I'm pretty sure if you graph this, or said y equals made a graph, like those would show up as vertical asymptotes, wouldn't they? Okay. All right, then we carried over to this page, okay, and did some algebra, factor. Guys, if you were not able to factor it, could you have used quadratic equation? Yeah, that would still give you the same two answers. So you guys got all that? All right.
No.
Right. Now, I want to do 3 more with you guys. These are going to be word puzzles. Right? And some of these we might just set up. And I want you to see at least what the setup is. Okay? Right, so this right here, solution. It says Avita adds 75% acid solution to 8 milliliters of a 15% acid solution. And I'm going to skip down to just question B. She's trying to create 50% acid. Right. So spell that out here. Number 13. And there's a few like this. In the pre-recorded video, I did another one that was like mixing solutions. Okay. So we got this. Here, have a couple of containers here. Can you guys draw a couple containers? All right, got some acid, and we're gonna spill this acid into some container here. Okay. Spill on some acid, spill on some acid. All right. Now, one container is 75% acid, and the other container is 15% acid, or at least that's like how acidic the liquids are. Okay. Okay. We got a very strong acid and maybe like a weaker acid. Okay. And what we want to create is a 50% solution acid. Right? Okay, guys, yeah. If we take something very strong and something kind of dilute, we can get something kind of in the middle. Does that make sense? Okay. And now they put one more number on this. They say that this right here is going to be 8 milliliters. Right. Okay, so now we have a hard quantity on one of the volumes. Okay. And the question is, how much of the strong solution should you add to the mix? So we'll call that x, and we can solve for x. Okay. Right. So there's a few of these. I definitely want to do word puzzles for this lesson, because there's a few of these word puzzles where they spell out the scenario like I just went over with you guys verbally, right? And you guys looking at. Okay. But you have to figure out how to set up the equation. Right. And of course, I'll take you guys through this one. Right. Right. So can you guys think how to do that? Well, how about this, guys? Whatever x is, I don't know. Maybe it's also 8 milliliters. Maybe it's a little less. Maybe it's a little more. Right. But when you combine it, what's the total volume going to be? What's the total volume? Is it this plus this?
Yeah.
Yeah, I think it's x plus 8. Right. Whatever x is. If you add the 8 over here, that would give you the total volume of the 50%. Wouldn't it? Okay. So what we're going to do is 75% solution times x plus 15% solution times 8 milliliters equals 50% solution times x plus 8 milliliters. Okay. So this is milliliters. Milliliters. Okay. Right, you guys got it? Okay. Now, what you're solving for is in 2 places. The x is there, and the x is also there. Okay. Could you guys distribute this 50% here? Okay. And there's a couple ways you can handle this. You can either strike all the percents and just work with 75, 15, and 50. Right. If you're in my physics class, I'd probably have you guys turn this into a decimal. Guys, what is 75% as a decimal?
0.75.
Yeah, 0.75. Right, no, let me go ahead and just write that way in case you wanted to solve that way. Okay. 0.75x plus, and what's 0.15 times 8? Okay. This all comes out to 1.2 if you multiply it out. Okay. Equals, and this is going to be 0.5 times x plus, and then 0.5 times 8 is 4. So that could be 4. Okay. Yeah, let's go ahead and actually finish this off. Just like a step away. So subtract this over. I'm getting 0.25x. Subtract this over. What's 4 minus 1.2? Getting 2.8. Divided by 0.25. I said times 1/3. So looking at x is 11.2, and that would be milliliters. Okay. Last thing to do is once you got an answer like this, step back, go back to the beginning and say, does that look like it reasonably makes sense? Okay. I mean, these volumes are comparable. 8 milliliters, 11-ish milliliters. Okay. That's kind of comparable. Okay. And 50 is not exactly halfway between 75 and 15, but it's sort of halfway-ish. Okay. So yeah, I think that looks believable. Okay.
Wait.
Okay. All right. You guys got that one? Okay. All right. Next one here. Looking at 15, I want to do with the guys. Construction. It says Rosita takes 32 hours. It takes Rosita 32 hours to drive all the basement by herself, and 18 hours if her friend Paula helps her. Right? I mean, it would take less time if she's getting help from a friend, wouldn't it? Right? How long would it take Paula to drive all the basement by herself, round to the nearest hour time? Okay. Okay. So this is a category of question that I want to explain a little bit more, like how to set this up and think about this. Right? This is one that shows up in the physics class, especially when we get to electricity. It's the same math that turns out as electric circuits. I should say resistors in parallel. That's what I'm trying to say. Okay? Here's a similar question with different numbers. Okay? It takes Alan 3 hours to paint the fence by himself. Takes Bob 4 hours by himself. But now that if they make a two-man team, how long does it take them? Okay. Well, it would definitely be less than either one individually, wouldn't it? Okay. Now the time comes out to this, and I'm making the claim that the way you can solve this is 1 over the total time is 1 over the first guy's time plus 1 over the second guy's time. Okay. But why is that the case? So let me convince you guys that that is the case. Okay. With this, takes. Okay. Suppose you want to do one job. Okay. Might be painting a fence, might be mowing the lawn or whatever we're looking at in the book. So one job. Okay. Well, that's the rate you do the job. So job per time. Okay. Like if you can do the job in 3 hours and your friend can do the job in 4 hours, that's the rate that you're doing the work, isn't it? Isn't this right here kind of like the rate of work? Okay. Times however much time. Right? Be like that. Now, if you get with a friend, right? So this is by self. So by yourself. Okay. But what if it's with a friend? Okay. Then that one job could be, I'll say the same rate as before, right? But maybe this is for person A, so I'll call it time A, right? Times some amount of time t. I'll call it plus your friend is also doing the job at their rate, so this could be time B, and then for some amount of time. Okay. But the thing is that yeah,
Next bathroom.
yeah, here, take this fast. Thing is that these two times right here, these two times are the same time because you're doing the job together and you're both working on it in parallel. Okay. This is called working in parallel. Okay, working in parallel. Now, guys, if these are the same time, could you just factor out that time and then you could divide it over? Okay, so one job over t total equals the rate that you're doing the job, so the job over time for person A, plus the rate your friend's doing the job per time B. Okay. Now, if it's job, guys, if all the numerators are the same, you just replace it with 1, 1, 1, like that. Okay. So 1 over time total equals 1 over time for person A plus 1 over time for person B. Okay. Now, for your textbook, when they were doing the examples at the beginning, you guys know at the beginning they do like 4 examples. Okay. This is one of the examples. Kind of, I don't think they super explained it super well, but this is the best explanation I can give you. Okay. So the concept here is working in parallel. Okay. You and your friends are all working at different paces. Maybe it takes you individually different times to like paint the fence or whatever. Okay. But it all comes down to this equation. Okay. So 1 over the total time working together. Okay. You're both paint the fence, mowing the lawn, whatever. Okay. It's 1 over the first guy's time plus 1 over the second guy's time. Okay. And if you had a third friend, then you could do 1 over. So I got Alan here and Bob here. So the 1 over the total time is 1 over Alan plus 1 over Bob. If they brought in Chad, plus 1 over Chad. And if they bring in a string of friends, plus 1 over Derek, plus 1 over Eric, plus 1 over Ferric, and they could like keep adding on friends and paint the fence really fast. All right, so let's get back to the book then. Back to the book. Okay. So the book here, we got. All right, we're gonna turn this into an equation. Right. Okay. Takes Rosita 32 hours, so number 15 here. So 1 over t total equals 1 over t Rosita plus 1 over t Paula. Right. Takes her some time to this dry basement, but okay, dry basement, another friend. Right. So it says if they work together, that's 18 hours. So I'll say 1 over 18. It takes her herself 32 hours if she was just working alone. Okay. And the question is, how much time does it take Paula if Paula was, again, just working by herself? Okay. So that's what the equation looks like. Okay. If you figure that out, then you can go and do the math. Okay. So, all right. Do you guys want me to finish this one out? Do you guys want to see the full solution? No? No? Okay. See, okay. See, you know, but you guys could solve that, right?
Yes.
Oh, right. So let's do one more. Number 16. Baseball says a major league team plays 162 games in a season. Halfway through the season, one team has won 60% of the games. What percent of the remaining games do they need to bring their winning percentage up to 75%? Okay. So there's 162 total games. Okay. And then halfway through season, they win 60% wins for first half of season. Okay. And they have a 75% win goal for entire season. Okay. So I'll say X percent wins second half of the season. Second half, right? So how many games have? What percentage of games do they have to win for the second half? And it would have to be an enormous percent, wouldn't it? Because if they're sitting at 60% halfway through, and they want to get up to 75%. Oh man, they really got to go on a winning streak, don't they? They got to bring their percentage way up. Probably have to win like almost everything. We're gonna find out. Really spoke. Yeah. Set up. Yeah. Okay. So you guys get the premise. Is there any question about that? Okay. And so how can you create an equation? I think that's probably the biggest puzzle is how do you create that equation? Because once you do that, then you can of course do the algebra. Okay, so about this, I think that it's going to be. Let's see. That's that for. 60%. So I can say 60% times. Okay, and how many games are you multiplying by to get like the number of wins? The number of wins. Cool. Well, it's not the total games. It's only the first half of the season.
So
Yeah, half of 162. So 162 over 2, because wouldn't that be the first half of the season? Right. So we're going to win this percent of this many games. Isn't this the total number of wins for the first half of the season? Okay. Plus X percent of the second half of the season, which would be an equal number of games, wouldn't it? So 162 games over 2 for the second half of the season. Okay. That has to equate to 75% of all the games. Ah, okay. So this is wins in the first half. This is wins in the second half. And this is wins total. Okay. Actually, I'm really curious to see what the answer actually is. Okay, so I'm sure you guys could do this at this point, but I'm just going to solve real fast. So it's 0.6 times 162 over 2. Okay, so it's like, oh, that's not even a whole number. What? 60%? You can't win 60% of that. Whatever. Okay, I got a decimal. That doesn't make any sense, but let's just go with it. Okay. Plus, and then 162 over 2. It's going to be 81x equals what's 0.75 times 162 is 121.5, right? We're going to make believe they could play decimals games, whatever. We could do an interpretation where you round or something. So let's see, subtract this over, divide by that. So it's 121.5 minus 48.6, then divided by 81. Okay. So yeah, so as a decimal, x is 0.90, right? And as a percentage, that's 90%. Yeah, so they have to win like almost every game from here on out to bring that percentage up that high. Okay, double check, make sure your name's on your notes. Turn the notes in the grade tray, give you guys points for those. And you guys got the rest of the class to work on Alex.